Hey everyone, it's that Math Magician. On this video, we're going to take another look at probability and we're going to see, can we use a tree diagram to help us solve a question? The question that we have today is listed right here for us. Speedy the rat is trying to learn the new maze below. If he randomly chooses a path each time the path forks, which room is he most likely to walk into? It says to use a tree diagram to help you solve the problem, to justify your conclusion by showing all calculations and the results of each room. So we're going to want to figure out here, what's the probability of him getting into room A, into room B, and then finally into room C? And then really, which one was the bigger number? What is going to be the bigger fraction, the bigger percentage? Which room is he most likely to get into? So for this problem, we need to make a tree diagram. So I'm going to zoom in here so that we can make it. Now, I'll give you a hint. We have a maze. We have Speedy the rat moving through the maze. That maze is really going to be your tree diagram. What you're seeing there shows you all the different branches that Speedy the rat can go down. What we have to do is basically just copy it down and then add all the information that we need for our tree diagram to work. Now, that point there is our starting point for our tree diagram. That point represents this point here, the first fork in the road that Speedy comes into. Now, when Speedy comes into this room, to this fork right here, he has three different ways to go. Notice he can either go up, or he can go straight down the middle, or he can go down. And the question said, whenever he gets to a fork in the road, he's either going to go down each path randomly. There's an equal chance of that happening. So if I have three different ways to go, the fraction that I'm going to put for each path along that route is going to be 1 out of 3. Because if there are 3 ways to go, he has a 1 1/3 chance of going down each route. Now let's follow him, Speedy, as he moves up. Let's say he took the top path. He's going to end up at this point right here, another fork in the road. Notice that that fork in the road splits again into 3 different options. He could go up, down the middle, or again, going down below. Now, again, 3 different ways to go. What's our fraction going to be if it's an equal chance? Every path there is going to end up being 1/3. Now, we're not done yet here, because now that we've gotten to the end of the pathway, we also want to add in the letter for the room that he ends up in. What I mean is, if Speedy the rat went up and then went up again, he actually ends up in this big room here, which is C. So I'm going to label that as C, because that's when he gets to room C. If he goes up and then goes straight down the middle, he's in room A. And then again, going up and then going down, he still ends up in room A. We just want to label these so we know exactly what room he's ending up in. Now, the middle path is going to be very easy for us because it's a straight shot right into room A. There is no other option for him to go, so that one just ends at A. No other branches really needed for that. But now we get to the bottom one, and notice that the bottom one has a lot of forks in the road here, actually 2 that we have to deal with. He's moving down this, he ends up here at this fork in the road, and he has 2 ways to go. He can either go up, or he can go down. Oops, I wanted those in black. He can either go up, or he can go down. If he goes the down route, notice he's going to end up here at C. And again, we want to apply some fractions to this, because now he doesn't have 3 options to go, he has 2 options. So because of that, his new fraction here is going to be 1/2 and 1/2. Now if he goes up on this fork in the road, he ends up at another choice for him to make. He again here is going to have 2 different routes to go. He can either go up or he can go down. He'll either end up though, or in both cases, he'll still end up in room B, but we do have to label that each of those are going to be an additional 1/2. So there is our complete tree diagram. I'm going to go ahead and move the other maze off in a second, but just look at the maze, look at our tree diagram. They're really exactly the same. The only difference here is that we have fractions added on to every branch along the route. That is what's going to help us solve this problem. And that's why it's so important that you draw it out on your own so that you have enough space to show all those fractions. Now, since I have this ready to go, I'm going to hide the maze because I think we're ready to actually solve this problem now. We're almost ready to solve this problem. We now have to figure out what are the probabilities of him ending up in each room. Let's start with the top room, room C, right up here. For him to end up in this room, notice he had to go up, passing the 1/3, and then up again, passing this 1/3. Well, in order to figure out what this probability is for C, I just have to take the first 1/3 and the second 1/3 and multiply them together. So 1/3 times 1/3 is going to give us a value of 1/9. The chance of him getting to that room C up there at the top is 1 out of 9 because 1/3 times 1/3. We need to do that all the way down this tree diagram. The chance of him getting to this room A would have to also be 1/3 times 1/3. So this will also be 1/9. The final A there will also be 1/3 times 1/3, which is 1/9. Awesome. Now let's do the middle A. This A down the middle, he just passes 1/3. He doesn't pass another fraction. So no need to multiply. We know that his chance of getting there is 1/3. Now we'll go straight to the bottom. Let's do the bottom C because the bottom C is a little easier. The bottom C here, he's going to pass 1/3 times 1/2, and 1/3 times 1/2 gives him a value of 1/6. Now our B's there, our B's that are left there, notice that these ones are different because of the fact, and I'm going to highlight this so we can see it. He passes by 1/3, he passes by 1/2, and then he's going to pass by another 1/2. Do you see that? He's going to have to pass 3 different fractions. So for us to solve these B's, we're actually going to have to figure out or multiply those 3 fractions along that route. So we're going to do, whoops, I did not want to delete all of that. We're going to have to take 1/3 times 1/2, which is 1/6, times another 1/2, which is going to give us 1/12. I'll write that out though so we can see it. 1/3 times 1/2 times 1/2, that's going to end up equaling 1/12. We got to multiply every fraction along that route. Same thing for the bottom B. It'll be the same 3 fractions, but there we go. We now have the probability of him getting into each room on each path along this tree diagram. I'm going to erase my work so I have some room to show my other work. Now, are we done with this question? Not at all. We still haven't answered the question. The question said, what's the probability of him getting into room A? What's the probability of him getting into room B? And then what's the probability of him getting into room C? In order to figure that out, we got to add up all the fractions for every single room. So let's go ahead and do that. For him to end up in room A, this A room here has a chance of 1/9. This one has a chance of 1/9. And that A has a chance of 1/3. We got to take those 3 fractions and we need to add them up together. Now remember though, we can't add fractions unless they have the same denominator. Well, the first 2 fractions definitely have the same denominator, but our third one here doesn't. We need to change 1/3 so that it has a 9 on the bottom. And that's actually an easy fix. We just got to take 1/3 and we got to multiply the top and the bottom by 3. So 1/3 becomes 3/9. We can add those all together now because 1/9 plus 1/9 plus 3/9. Remember, we don't add the denominators, we just add the top. So 1 plus 1 plus 3 gives us an answer of 5/9. The chance of him getting into room A is 5/9. Let's go ahead and do room B. Room B is actually going to be a little easy for us because it only has 2 fractions and they already have the same common denominator. 1/12 plus 1/12 is going to give me an answer of 2/12. Whoops. Going to give me an answer of 2/12, but we can reduce that because 2/12 reduces to 1/6. All right, our last room, room C. We want to go ahead and add up those fractions. Only 2 again. The top one is 1/9. The bottom one is 1/6. Notice that they do not have the same denominator, but we can definitely change them to have the same denominator Think of the least common multiple for 9 and 6. I think 9 and 6 both go into 18. 18 is the least common denominator here. So because of that, I'll have to take 9, multiply it by 2. So we'll have a 2 on top. And then 6 we'll have to multiply by 3. So we have a 3 on top. And what is 2/18 plus 3/18? Well, that ends up being 5/18. Now, a lot of work, right? We drew the tree diagram. We found out all these red fractions here at the end of each route. We've now added them all up so we see every room. And we have the probability of every single room. But we still have not answered the question because the question said, which room is he more likely to go into? Well, we have all these fractions. We just have to figure out which one is the largest. And what's tricky about this one is that all of the fractions here have different denominators. So it might not be as clear to all of you which room has the largest percentage here. So to actually figure this out, let's change these fractions into percentages. And to do that, to change a fraction into a percentage, just take the top number, divide it by the bottom number. So I'll start with room A. Let's take 5, let's divide it by 9. It ends up equaling 0.55555 repeating. Well, we'll move the decimal over 2 spots to get our percentage. So this actually ends up equaling 55.55%. That is the probability for room A. Let's go ahead and do room B. 1 divided by 6 ends up with 0.16666 repeating. Again, move that decimal over 2 spots. So this should end up equaling about 16.67%. All right, last but not least, let's do room C on the very bottom. We got to take 5, we got to divide it by 18, and we end up with a percentage of about 27.78%. So you're trying to figure out which room is he more likely to go into? I think it's going to be room A. Room A, it's the largest percentage, and it's also the largest fraction that we have there. But that's how we work these problems out. This is a complete tree diagram off of this maze. Let's not forget what we were working with. There was our maze, we made our tree diagram, we solved it out. Does this problem take a lot of work? Yes, you betcha it takes a lot of work, but persevere through it, work through the fractions. The math isn't complicated, but if you set it up incorrectly, then you might get the wrong answer. It's That Math Magician, and I'll see you on the next video.